Hello everybody, welcome back to this channel. Thank you very much for joining us once again. I know it's been quite some time without uploading any video, but nevertheless, here we go. Yet another session. We're going to look at November 2022, paper 1, focusing on question 9. Okay, question 9. Given f of x is equals to x squared, determine the minimum distance between the point 10, 2 and a point on F. Okay, so how do we solve this question? So basically this is the application of calculus, and we are getting that because we want to find the minimum distance, right? It's actually the minimization of the distance. Remember, in application of calculus, we can also minimize the cost. We can also minimize the volume, right? We can also minimize the area, the surface area, and all that. But in this case, it's quite a challenging question, really, because they want you to minimize the distance. So in order to answer this question, really, you must look at this keyword, determine the minimum distance. Then you know, oh, this is actually the minimization of the distance. We have to minimize the distance, right? And you have to recall now, make a connection with how we we minimize the volume. If we are given an object and they say find the minimum volume of this thing, what is the smallest volume, or rather what is the maximum volume, or rather if we are talking about area, if we are talking about cost, how do we minimize? And I think we covered that section on application of calculus on another video named application of calculus in this YouTube channel. So I'm just gonna post the link on the description of this video. You can just go to the description, you get the link of the application of calculus, so that you can really conceptualize how we actually apply calculus, the knowledge of calculus, in order to minimize things, right? So the keyword there is minimization. Hence we are able to make relational connection to say, oh, actually this is application of calculus, right? We have to minimize the distance. So it's quite tricky because they didn't even put a diagram for you, but you can just make a diagram to simplify the question. So this is our parabola, f of x equals to x squared, right? I'm just going to call it f. So what's happening is that they gave you a point somewhere. Let's just put this point here, which is 10 and what? And 2. Then they're saying, find the minimum distance between this point 10 and 2 and a point on F. But someone might be wondering, we don't know which point. Hence, we have to actually find that point that will actually minimize this distance, right? In a way. So we want to minimize, we want to find the minimum distance between this point 10 and 2 and a point on F. What is the point on F that will ensure that we get the minimum distance between 10 and 2 and that point? So because we don't know that point, we can just call it X and Y, right? Because a point is made of X and Y. But in this case, because it's a point on F, instead of putting Y, just to express everything in terms of X, we can just put what? F of X. Because we do know that y and f of x are what? Are the same. We know that y is equals to f of x. Hence, I'm just replacing my y there by f of x, right? So now, how do we minimize? That's the biggest question. How do we get the minimum distance between these 2 points? Now that we have created a point, right? It's unknown actually. We don't know what is x. We don't know what is f of x. But we do know what is f of x, right? Because we are given in the equation that f of x is what? Is x squared. In other words, I'm just going to transform that point. Or maybe let me put it down. We have a point on f, which is xy, right? Then what do we do? We replace y by what? By f of x. Then again, we said, no, we do have f of x. It's given as what? F of x equals to x squared. So it means that we want to find the minimum distance between the point 10 and 2 and a point on f, which is what? Which is x and what? X squared, right? Which is our y, which is f of x, in other words. All right. So I hope you got that. So I'm just gonna replace this by what? By x squared. All right, this is my x and this is my y, which is f of x. In this case, is given as x squared. So this is a point on f of x. So what do we want to do? To find the minimum distance. Okay, so how do we minimize something? If you have watched our session on application of calculus, we said mathematicians have come up with a fantastic way in which we can minimize things such as our cost, such as our profit. We can maximize our profit, minimize our cost. We can minimize, maybe we calculate the minimum surface area uh, that maybe if we want to build something it can occupy. We can also find the minimum volume of our object and all that, and rather maximum volume and all that. But the question is, how do we do that, right? So the first step, and you can just also go and rewatch that session. I think it's very important in your understanding application of calculus, because this question is just basically on application of calculus. Okay, so but the question is, how do we do that? How do we minimize the distance? How do we minimize the cost? How do we minimize the volume? In this case, it's distance. We want to get the minimum distance. How do we do that? First step, you get an expression of something that you want to minimize or maximize, right? So you get an expression in terms of variable. So in this case, we're going to use x as our variable, right? Because there's another point which is already written in terms of x that we just created in our function there. Okay, so now the first step is you create an expression, a mathematical expression or equation for something that you want to minimize. Very fantastic. Then what do? You go and derivate that expression. Ensure that that expression have the same variable such that you can be able to derivate, right? So after derivating, equate your derivative to 0, solve for that variable, and go and check if maybe you are solving and you are getting maybe 3 answers as the answers of the variable. Go and check between those 3 answers which one will minimize that thing that you want to minimize. So basically that's how we approach such kind of question of optimization, where we have to maximize or minimize. Similar to this question, we want to minimize the distance. What do we do? Step number 1, you get an equation or an expression for something that you want to minimize. In this case, we are going to get an expression or equation for the distance because we want to minimize the distance. We do know already the distance formula, right? So the distance formula is d squared is equals to x2 minus x1 squared plus y2 minus y1 squared. Okay, so we can just name our 2 points because we already have our 2 points. I'm just going to name this as x1, and this will be what? Y1. Then this will be what? X2. This will be what? Y2. Okay, so now to get the distance formula, so this is just from the distance formula, right? So to say d squared is equals to x2 minus x1 squared plus y2 minus y1 squared. Okay, so d squared is equals to, what is our x2? It's 10 minus what is our x1? Is just x. We don't know because they just say a point on f, and a point is made of x and y. In this case, we have just replaced y by x squared because it's on that function which is f of x. Okay, so now we have x2 minus x1. In this case, it's 10, which is our x2, minus our x1 is just x. We don't know that. This is squared. Plus y2. What is our y2? It is 2 minus what is our y1? Our y1 is actually y, right? Which is the same as, because it's on the graph f of x, we are replacing y by f of x, but we do know that that f of x is the same as what? As x squared. Hence, don't be confused to say, where is this x squared coming from? So it's the same as x and y. We don't know that point on the function, but we do know that y is actually the same as f of x, and our f of x is what? Is x squared. Hence, where there is y1, we put what? We put x squared there, because that's what it's equivalent to that function. Okay, so from there we can just go now and expand these and simplify at the like terms, and let's see how it goes. Okay, so when we expand our 10 minus x squared is going to be 100 minus 20x plus x squared. Then when we expand this one is going to be 4 minus 4x squared plus x exponent 4. Then when we group the like terms and add them together, our distance squared is equals to x exponent 4 minus 3x squared minus 20x plus 100. Okay, so we are done with step number 1. If we want to minimize something or maximize something, what do? We have to first create an expression or an equation for that thing in terms of one variable. So in this case, we are using x, right, as our variable. Then the second step is we have to derivate that equation in order for us to get those stationary points. And someone might be wondering, why when we want to minimize something or maximize something, we have to derivate? Okay, recall from your cubic function, how do you get the maximum turning points? How do you get the minimum turning points? What do? Is you go and derivate, find the derivative of that function. Maybe you are given g of x, you go and get the derivative of that, right, and equate it to 0. And the reason for that is that we do know that at the turning point, at the maxima, at the minima, your derivative is actually equals to 0, meaning that the x values that you'll get is actually those x values at those stationary point at either your maximum or your minimum. Hence, we have to derivate if we want to get the maxima or if we want to minimize something. Okay. Okay, now we are done with our step 1, right? Of finding an expression or an equation for something that we want to minimize, in this case distance, right? So I use the letter D there. So it is squared. Distance squared is equals to x exponent 4 minus 3x squared minus 20x plus 100. Someone might be asking or wondering, why are we not maybe applying the square root finally just to get our distance in terms of in this way, minus 3x squared minus 20x plus 100. Why are we not doing this? Okay, we do know that if we come and apply the square root there, it's going to be very hard for us to move to step number 2 of finding the derivative of our expression, because we have a square root, because that's applied in university. When you go to university, you learn how to derivate things, expression like this. Hence, we are keeping it as d squared, so that we do know that here we know how to derivate that, right? We know how we can derivate that. But if we come and apply the square root, maybe to solve for d, to say distance equals to the square root of something, it's going to be very hard for us to derivate this, because you haven't learned this content in your grade 12, right? But you do know how to derivate that. So that was also another trick to understand that actually you don't need to apply the square root, because actually when you find stationary point, the stationary point that you'll find here actually will be the same as when you apply the square root there, right? So in a way, but also to think that if you apply the square root, it's going to be very hard. You won't be able to derivate that expression. Hence, we are leaving it at d squared, so that we can just go and derivate it at d squared and find our stationary points. Okay, so what we're gonna do now, we have to find the derivative of our expression. Okay, so to represent that, now I'm derivating. I'm just gonna put a dash there to say I'm now finding d2 prime, in a way, d2 prime. Right? In other words, I'm derivating this, right? So how do we derivate this one? X exponent 4, you do know from your derivation rule, you multiply the coefficient of x with that exponent. So 4 times 1 is 4, then you go to the exponent, you subtract 1, then you'll be left with 3. Okay, same. How do we derivate this? We use the power rule. It's called the power rule, right? We take the coefficient of that, minus 3 times 2, that is minus 6. Then we subtract 1 on the exponent, you are left with 1. Okay, so I'm just going to leave it there. Here you have 1, so minus 20 times 1, it's minus 20. You go to the exponent, you subtract 1, it's going to be x exponent 0. X exponent 0, anything exponent 0 is the same as what? As 1. So it will be like minus 20 times 1, which is minus 20. The derivative of a constant is 0. So we won't even put 0 there, because it won't change anything. Okay, so now this is our derivative. What do we do now? So this is our derivative in terms of x. We can just put it that way. So now we're going to equate our derivative in terms of x to 0 so that we can go and get those x values that will actually minimize or maximize this distance. Okay, so now we get our expression for x exponent 3 minus 6x minus 20 is equals to what? Is equals to 0. Then now we want to solve for x. You have your cubic function. How do you solve for x? How do you factorize your cubic function? You have to know how to factorize this cubic function. Because if you don't know how to factorize this cubic function, it's going to be very hard for you to solve for x. Okay, how do we factorize a cubic function? First step is for us to get a what? A factor. Right? How do we get a factor? You go and substitute the values between minus 3, maybe up until the maximum 3, right? Minus 3, minus 2, minus 1, 0, 1, 2, or 3. You go and substitute those values where there is x. So you go and put minus 3 first. You check which of those values will give you an answer that is equals to 0. Then you get your factor. Right? So when I did it, I get that 2. When we actually put 2 where there is x, if I say 4, 2 exponent 3 minus 6, 2 minus 20, the answer gives me 0 when we punch the calculator. Meaning that when x is equals to 2, 2 is a factor. Okay, so we now know that x minus 2 is a what? Is a factor, because that is when we say x equals to 2, our function of the derivative is equals to 0, meaning that x minus 2 is a what? Is a factor, not x plus 2. Don't make that mistake, because we are saying when x equals to 2, so if you take this to that side, you get x minus 2 as your factor. Okay, so now we have, if we want to factorize this, we now have one factor, which is x minus 2 as our factor. Now we have to find these remaining factors now, right? So it's very important. The other trick part of this question is that your expression here does not have another term. It's missing just one term. That will be very, very important for us when we factorize. So let me just write it here for you. 4x exponent minus 3 minus 6x minus 20 is equals to 0. Then if we have to include all the terms, right, x exponent 3, if I have to put the one with x exponent 2, I'm just going to put 0x exponent 2, right? It's like we're adding nothing because it's 0 in a way. Then minus 6x minus 20 is equals to 0. Then so that it can be very easy for us to factorize. Okay, so we now have determined that x minus 2 is a factor. So x minus 2 is our factor there. Then we do want to get this other factor here so that we can simply go and solve for those x that will either minimize or maximize. Okay. Okay, now the question is, how do we find this? So I'm actually using this method. I think it's called inspection or something, but it's the K method where we use K and stuff. So we have to first get this term here. How do we get this first term here? So you ask yourself, what can I multiply this first term here with this one in order for us to get 4x exponent 3? So basically that will be 4x squared. Because we do know that x multiplied by 4x squared will give us what? Will give us what? 4x exponent 3. Hence the term there must be 4x squared. Then you go to the last term again to say, okay, in order for us to get minus 20, what must we multiply this last term here? Minus 2 with. Minus 2 multiply with what? Must give us minus 20. So you can see that actually that must be what? Positive 10. If we take minus 2 times positive 10, it gives us minus 20. Okay. Now you are done there. So the K method says for the middle term, you just go and check your middle term there, which is negative 6x, right? Then because it's negative for the middle term, you just change the sign. So it will be positive kx there. Okay, so it's the K method really. You can use any method for you to get the factors so long as you use the correct mathematical approaches. Okay, so now we have to solve for K in order for us to really find this factor. How do we solve for K? So what you basically do in this case is you're going to take the last and the first, right? So this last year and the first, you multiply them, you're gonna get what? Minus 8x squared, right? And this first and this second one there. So that you actually get those two, that when you multiply them, you'll actually get something with the coefficient of x squared. Okay, so it's minus 2 times 4 minus 8x squared. X times plus kx is going to be plus kx squared. Then we'll equate this to something that is equals to something that is a coefficient of x squared in our expression there, right? So it's going to be 0x squared. So you do know that if you didn't put that 0x squared there, it would be very hard. Hence this question was quite really tricky and also quite challenging, because you also have to recall how do you factorize a cubic function in order for you to solve for the x values. Okay, so now what we can do now is we can go and solve for our k. How do we solve for k? We can take minus 8x and transpose it to the other side. We'll have kx squared is equals to 8x squared, because that is 0. So anything added to 0, it will remain the same. So to solve for k, we can divide both sides by x squared. X squared and x squared will cancel. Then k is equals to what? K is equals to 8. Okay, now that we get k equals to 8, where there is k, I'm just going to put 8. Then we now got our factor for x squared plus 8x plus 10. This is equals to 0. We do know that x minus 2 will be equals to 0, 0 factor rule, or 4x squared plus 8x plus 10 is equals to 0. We do know that here x equals to 2, right? That's our first value of x. Then when we come this side, we can rather use quadratic formula to solve for x, where x equals to minus b plus or minus the root of b squared minus 4ac. If you forgot how to factorize, you can come and use this quadratic formula to solve for your x. Okay, so when we substitute from our equation to solve for x, our b is 8, so it's going to be minus 8 plus or minus root of 8 squared minus 4. What is our a? Our a is 4, our c is 10, divided by 2 into a, which is 4. So when you solve for x, when you punch your calculator, it's going to be no solution on this side, because there you have a root of a negative, right? So it's there's no solution for that. So it means that this function only has one root, which is x equals to 2. Okay, so now we can go and answer the question. Remember, the question said find the minimum distance between a point and 2 and a point on f. Now what we were doing is we were finding that x value that will minimize that distance. So we only got one x now, which is x equals to 2. So remember, if you had maybe 3 x values, different x values, you were going to your function and test which one will give you the shorter distance between the 3 x's that you got. So now here we are fortunate, we only get one x value, which is x equals to 2. We go back to our equation, we substitute 2, and we get that minimum distance. Okay, all right, now we can return back to the distance formula, to the expression that we had, and go and substitute our x equals to 2, because we found that when x equals to 2, that's the value that will actually give us the distance, the minimum distance. Okay, so let me just highlight just a slight error that I just made here. This is 100 plus 4, so it's just gonna be 104. Just so it won't change anything previously that we did. Everything is fine, so you can just highlight that it should be 104. Then we can now come and get the distance. Remember, this is squared, right? But we do know that distance, we have to apply the square root finally. So it's 2 exponent 4 minus 3 into 2 squared minus 20 into 2 plus 104. Then to get the distance, we're just going to apply the square root of this. So distance will be the root of this, 2 exponent 4 minus 3 into 2 squared minus 20 into 2 plus 104. Then we can punch in our calculator and see how much we get. So it's giving us 2 root 17 units, which is the same as 8.25 units. So that will be our distance.